Hello again, and welcome to another GCSE Computer Science Theory lesson. This video is going to be on Unit 5, Network Security. So I just want to do a brief overview of what we're going to cover in this video. We're going to cover MAC address filtering, encryption, authentication, and firewalls. And also an extra special bonus for you at the end of this video. I'm going to talk about how you can exploit these security methods. But first, let's talk about MAC addresses. Now, MAC addresses are a globally unique serial number hardwired into network hardware. Might be hard to believe, but every single device that is connected to the internet has one of these MAC addresses hardwired into them, and they are all unique. So you won't find two MAC addresses the same anywhere in the world. Hard to believe, but MAC addresses, they're such a big complex number. The odds of you getting two the same is just mathematically impossible in our lifetime, or maybe even the lifetime of the universe for that matter. So just trust me, they are globally unique, and they are allegedly hardwired into your devices. Except for what I'll show you at the end of this video. I'll show you where you can get around that, but for the purposes of the GCSE, they are hardwired into network hardware. And note that I say network hardware and not PCs or smartphones, because they are actually hardwired into the things like the wireless cards. So your laptop will have a wireless card on it. The MAC address is inside the wireless card, not the laptop. Same for your smartphones. The MAC address isn't built into the smartphone, it is built into the wireless chip that is inside your smartphone. Okay, so a security method that you can use as a network technician is something called MAC address filtering. So given that every device in the world has a MAC address and that they are all globally unique, then you can blacklist some of those devices. So if there are any dodgy devices, if you have any weirdos on your network who have been doing some damage, well, you can just block their MAC address and then they can't connect to the network anymore. Happy days. Alternatively, you can use something called whitelisting. So you can block every single device automatically by default and only allow a few select devices onto your network. So if we were using a classroom, for example, you could by default block every single MAC address in existence on the net in the world and only allow just those 30 machines that are inside your classroom. So moving on to encryption. So encryption, and this is a definition you should know for the exam. Encryption is the art of scrambling data to make it unreadable to those who do not have a decryption key. By the way, you need to talk about having a decryption key to get the mark in this exam, because if you just said encryption is scrambling up data, well, technically taking a file and deleting it or overwriting it with some random junk, that's technically encryption by that definition, which it is not. So the whole point about encryption is that it's a two-way thing. So you can scramble up data, but also unscramble data if you have the decryption key. So the next thing you need to know about is something called authentication. And authentication is just the idea of using a username and a password to get onto a computer network. So Windows, for example, has some authentication software built into it. So generally speaking, computers in a business environment or in a school, as an example, there is normally a massive server somewhere in your basement that contains all of your username and passwords, and whenever you connect to the internet, that has to be authenticated using some networking hardware. So here's a little screenshot from Windows, something that you might see when you're using a computer in work or in school. Also, authentication doesn't have to just take the form of Microsoft Windows. It can also be something built into one of your wireless routers. So let's take a hotspot that I've got near me, for example. So there you go, look, this Virgin Media hotspot that I'm trying to connect in requires both a username and a password. And just because I want to see what happens, I'll eat my hat if this works. I can't connect, didn't think it would. Okay, moving on. Firewalls. So firewalls act as a barrier that only predefined traffic can pass through. Alternatively, we could describe this the other way and just say a firewall blocks traffic based on predefined rules. And that's everything you need to know for GCSE in terms of networking security. What I'm going to talk about now is completely optional, so only stick around if you want to know about firewalls, Wi-Fi passwords, and MAC addresses in more details, and potentially some strategies on how to exploit them. Okay, so let's start off by talking about MAC address security and why it is very easy to bypass. Now, let's say you've been connected to a network and your MAC address has been blocked. How can we get around that? Well, we just change our MAC address and then we can connect to the network again. It's as simple as that. If you're not sure how to change your MAC address at home, then we just go into Google, how to change your MAC address, and the first thing that comes up is a nice little tutorial that tells you how to change your MAC address on Windows. Some of the other applications to changing your MAC address, it can help you get free internet when you're in airports and hotels. So for those who aren't aware, usually when you try to use the Wi-Fi in a hotel or an airport, you're only given about 15 minutes free as a trial. And then you have to pay per hour after that. Now, these organisations usually use MAC addresses to keep track of who is on their free trial and who has paid for a premium. Well, if you run out of your free trial, just change your MAC address to something random and you can just start a brand new free trial again. So there you go, free internet. So moving on to Wi-Fi passwords, there are two different types of Wi-Fi encryption, or two major types of Wi-Fi encryption that is commonly used today. So one of them is called WEP, another one is called WPA2. Now you don't see much WEP these days. Most of the time routers are using WPA2, but if you are lucky enough to come across a WEP encrypted router, it's going to take you about 5 minutes to crack that password. And you don't have to do the cracking, you can use some software that will do it for you. I'm not going to tell you what that software is called, but I am going to just say that there is this really cool operating system called Kali Linux. However, if you were to try and attempt to crack WPA2 software, it's going to take a very, very long time. We're talking about months and months and months to try and crack a WPA2 password in terms of regular computer hardware. I mean, if you had a supercomputer, it would do it much faster, but we're talking about normal computer that a typical person might have in their house. It's going to take months to crack this. However, there is an exception to this. There is a weakness you can exploit, and it is to do with weak and default passwords. So typically, when you buy a router from a supermarket, or if you get a router 3 with your internet connection, it's going to have a default password on it. And sometimes these passwords are set to something like A, B, C, D, 1, 2, 3, 4. And people can guess these quite easily. So there's one weakness there. But here's the thing. The reason why WPA takes so long to crack is because WPA is about 24 characters in length, and you can use symbols A to Z, lowercase a to Z, and also a bunch of punctuation and other symbols on your keyboard. Put all those different combinations together, you're talking about months and months and months. Here's the kicker. Certain manufacturers of routers that I will not name do not take advantage of all of these different possible combinations of passwords. There are many routers out there whose default password is 8 characters long, and it's a random combination of digits A to Z only and 0 through to 9. By the way, that only gives you about 65,000 different combinations of passwords, and that would take roughly a few minutes to crack. So, talk about a few minutes to crack a password of that complexity. So there are definitely, WPA2 isn't something you can normally crack, but if somebody hasn't changed the default password on their router, then the chances are you could crack into it. Okay, so moving on to firewall security. So a firewall typically works by either blocking a IP address or a web domain. So for example, you could configure a firewall to automatically block certain IP addresses and certain domains, such as facebook.com. By the way, this is not Facebook's IP address. I'll just put in a random IP address here just for the sake of this demonstration. Now, why would a company ever want to block IP addresses or domains? Well, there's a few reasons. There might be some dodgy websites out there that are associated with viruses and malware. So for security reasons, an organization or a school could choose to block a bunch of known malicious IP addresses or web domains. The other reason for blocking IP addresses in an organisation or a school is to block inappropriate content. It is to stop students and workers from getting onto rude websites or otherwise inappropriate websites that they shouldn't be looking at in work or school. Another reason why an organisation might choose to block IP addresses or websites is for productivity reasons. So many organisations and schools block Facebook not just for the purposes of safety, but to keep their workers happy and productive. Like, let's imagine you were the boss of a company. The last thing you want is to have your workers slacking off and prattling about on social media. So you're going to block all that stuff so they can't use it. However, there are ways you can circumvent this firewall, and that involves using a proxy. Now, you can just get these things by typing them into Google. So if you just Google, VPN or free proxy, you can get something up. And in this case, I'm going to go to a website called WikiLeaks, and I'm going to connect to it using a computer in Germany. So as far as my firewall is concerned, I am not connecting to wikileaks.org, I'm actually connecting to a random computer in Germany. But that computer in Germany is going to be redirecting this website to my computer screen for me. Okay, here we go. Here's good old WikiLeaks. By the way, don't use VPNs or web proxies in your place of work or school. Chances are they've been banned by your school, and there will normally be some kind of repercussions. For example, where I work, if a student is caught using a web proxy, they will be banned from the school computers and possibly excluded from the school from a week. Okay, so one more thing, and I hope that you might find this interesting. You could change the MAC address on a Nintendo Wii if you wanted to. The question is why? Well, back in the olden days where you could play online on the Nintendo Wii, you could get caught cheating. So if you were caught cheating playing Mario Kart on the Nintendo Wii, Nintendo would ban your console. To do this, they would block your MAC address from their servers. So to get around that blockage, you would just change your MAC address to something else. But how could you do it on a Wii? Like, the Wii didn't have an operating system such as Windows to follow a tutorial on, so how did it work? Well, if you were using a homebrew Wii, you could load up a cheat engine and then just run through some cheat codes that would change your MAC address for you. Isn't that fun? By the way, I don't think this will work anymore. I think the Mario Kart Wii servers have been long dead.